Hello everybody, this is going to be a quick video on when to use subclassing versus composition. Let's just get right into it. We had a question on the synthesis and questions, or a couple of them. When is composition a better choice over inheritance? Just, referencing when Professor Grossman was talking about um, when to use this pattern instead of subclassing. So let's just sort of give an example of what he's talking about. So in this situation, I've made sort of a wrapped set. I want you to imagine that Java doesn't come with a set, um, and we want to make a wrapped set. And I'm going to use as my implementation an array list. So I'm going to delegate all of the responsibility off to the array list when I can, and I'm just going to build add such that it checks first to see if it contains it, right? So like an array list, a list is not a set is not a list, but I can use it and I can just check ahead of time. All right, make sure that the delegate contains it already, just return false. It doesn't actually add it in or something. And then to let you know that, and then otherwise just return, the delegate adding it in. I'm going to build contains that just offloads, size just offloads the work, remove, that works, iterator, that works. So I'm just going to for all the methods that I want, I'm just going to offload it onto the array list. On the other hand, if I have inherited, I build a set that's inherited, I'm just going to say I extend array list. Okay, so now all I really have to do is I'm going to override add, of course, because I got to check contains, which of course array list has. If it contains it, I'll return false. Otherwise, I'll just call my superclass on it. This seems good. I mean, then I've got this bonus method to add index at element. I'm not sure that makes any sense really for a set, but okay. Um, and now I'm all right, so now I don't return Boolean anymore. What this is supposed to do is throw unsupported exceptions. So, okay, I guess that's the right thing to do. Otherwise, I'll call add. Now I'm all right, I'm investigating this thing, and I'm all right, so now there's set at index. That doesn't have one of these. What am I even doing here? Maybe I'll switch to linked list now, but maybe array list performance is better. So now I'm changing which class I want because I get too many things going on. All right, so I switched to linked list. Okay, and then I want you to imagine that add all used to work by calling add. And at some point, one of the versions, they decided, oh, we can improve this. And so after you've released inherited set, the implementation of add all changes from calling add over and over again to doing its own thing. So now I got to go back and override this one and this one. I got to figure that out in the middle, right? Nobody, Oracle or Sun or whatever, doesn't send you mail letting you know they're going to change this thing, right? So it just sort of happens in some version and things start breaking. You're like, oh, all right, let me override these guys now, right? This is some bonus stuff now where both of these guys have to overload equals theoretically because we're not really equal to lists, are we? I guess maybe you could hope for that. ToString is the sort of thing where well, maybe the implementation of that is okay over here. But maybe it's printing out list, or maybe it does later. You kind of have to do that one too on both sides. What if array list or linked list, whatever you decided on, adds new methods, right? Are you gonna forever maintain both of these? And then how do I make it so it works for all these different versions perhaps also? So this is not a completely contrived example. There's a reason why a lot of people don't like extending things. One of the more famous ones is Java Util Properties, which has been out since the very beginning. It's sort of a way in which to maintain things. They literally wanted to make this guy have get properties and set properties and go from string to string. And they extended hash table, which is this other class, which at the time could only go from object to object, right? And they had all the other methods. They literally wanted this, put these methods in, and still extended hash table for reasons I have no idea. And I'm pretty sure everybody who followed up that decision still can't get their head around it. The other classic example of sort of screwing up is they had Java util stack extend vector. First, why is this not an interface? I don't know. The other one is why, this is a kind of, I guess, debatable. Why would methods other than push, pop, and peek be a good idea for something that's a stack, right? Vector is going to have a ton of different methods on it to be able to insert into locations and like do all these other things and access the first and last element, right? And that is not a stack. A stack does not have random access. A stack has a way to push, pop, and peek, maybe, or top, whatever you want to call it. Any other methods, it's like, why is this useful for stack to have this? And one of the arguments against inheritance is that these two implementations, whatever, even if it was a good idea, right, are now coupled together forever. Like you've added new constraints to your system, and the question you have to ask yourself is, are you prepared for that? Because now you're like, we are now stuck with this cruddy stack forever. Like they've replaced it. There's now Deck. They're like pushing this whole other thing. Still, like stack is hanging around, extending this terrible vector class for all time, and you just kind of like, once you make this decision, you're locked in and have to support it forever. There's some other things. A lot of people, if you just search, do a Java Google search on composition versus inheritance, you'll find a ton of people who are like going on and on about how this is a terrible idea. That composition is always better. You should never use inheritance. Some say you should only inherit interfaces, right? So like, people will ask this question, I'm sure, are not there. I'm not there either. I love inheritance. It's sweet. So let's talk about like what you should do to figure out what you should be doing. First question you should ask yourself is, every B really an A? So I want you to imagine this imaginary conversation with myself. I said, is every B really an A? And I'm like, oh yeah, it is. And you're like, you just want some of that sweet code reuse, don't you? Like, seriously, is every B really an A? And it's like, well, like you're going to subclass this, aren't you? Right? And so what we kind of mean by that is there's a lot of times where like the reuse is so good or so sweet, you're like, oh, I'm going to make this happen. But if it's not really an A or doesn't pass the ISA test, it shouldn't extend it, period. But there's a lot of bonus reasons too. So like one of the things is this Liskov substitution principle. I linked to the Wikipedia article. But basically, substitution principle goes from, like, if B is a subtype of A, then all B objects should be able to be used anywhere A is used, period. There should, as a bonus, there should be no surprises, right? You can never require more in your preconditions, right? You know, like whatever you're requiring for input, they have to be the same or weaker, and you can never deliver less, right? Like you must always be stronger in your post conditions or the same in all things, right? So my quick question for all of you is, should mutable list extend immutable list? So if you think about the functions of immutable list, they'll have a couple of them, like you know, how to iterate over in it, does it contains, and mutable list would theoretically have all of those methods and more, like add. And so the question is, should mutable list extend immutable list? Pause, think about it, and come back. Okay, we're back. My answer is clear. Like I would say the answer is no, but like, you know, perhaps I'll just say my answer, and most people's answers who've thought about this is no, it should not extend that. It breaks the contract of immutable list, that is, that it's immutable. And this gets back into this no surprises sort of thing. Anybody who's using an immutable list should reasonably be able to expect that it's immutable, right? Imagine that you memorize the length of an immutable list you were passed, and surprise, it's actually mutable and it changes, right? And that should never happen. And there's a lot of times when people are like, oh, it's okay to like do this extension or whatever. Like in general, right? It has to be a very strong case of, you know, any object of A can be used in any situation where B can, and there's no surprises. So on a side note, Kotlin, who seems to have cleaned up a lot of Java, seems to sidestep this issue with like list and mutable list. List is exactly like an immutable list. It has those things. It even says something like read access to this list. They have mutable list, which extends that. They didn't call it immutable list, I guess, and but you're sort of expecting this immutable list to be able to be an immutable list. I'm not the biggest Kotlin expert, so I couldn't find immutable list. Maybe they have it, but this whole, that's what I would do is if I was writing stuff in code, I was immediately something called immutable list that extended list and wasn't one of these. It wouldn't add any new methods, but then at least I would know that it wasn't one of those. Okay. Another question to ask yourself when you're doing this, is the class you would like to extend designed to be a superclass? Like one of them is it abstract, right? Like if something is abstract, it's literally been, you can't make an instance of it. It's been designed to be a subclass, that sort of thing. The dark side, and this is what most people sort of go with, is, well, if it's not final, that means they didn't preclude it, so it's obviously open for business. Instead of asking for trouble. Like, does it provide specific instructions on how to extend it for, and like that it'll be maintainable? So for example, Java has built abstract map literally in the documentation. It tells you what to do and how it's intended to be used, so that you can build your own maps. They allow you to override whatever you want, but if you just override entry set, for example, most of the functions in here will work. Same thing for abstract collection. It's like if you get iterator to work and size to work, most things will work. You can override other things if you want to improve the performance or whatever, but these are sort of an example of classes that have been built explicitly to allow people to override them or to extend them. Another question, and this is sort of unrelated, is do you have complete control over this superclass? That would impact my decision on whether or not to actually do this. If it's under my control, I'm much more likely to extend it. The other one that you have to be very careful about is, are you prepared to co-evolve your class with this superclass for all time? And you should be prepared to do that, right? Anytime the superclass changes, you're going to need to make sure that your subclasses are in lockstep with any changes they've made. It's my favorite little conspiracy theory that I got going on. It's like, I want you to imagine the following conversation, or I can imagine a student saying this to Professor Grossman and to a lesser degree me. Okay, so like Java made it so the class definition also serves as a type. This was sweet because it means like I don't have to make an interface for every single class, but okay, all right, you say I have to do that, so I do that, I make an interface. Like, and to go a little off script here, like, like it's tough enough to name everything, but now I got to have like an interface which has the actual name that I want. And then I'm like, all right, default list or default set is my actual thing, but all right, I like do that, I buy it, right? But now you're telling me I shouldn't use the sweetest bit of code reuse ever invented, subclassing. Like, you just want me to like functional programming better, don't you, right? Like, you're killing like the best bit of code reuse ever made, like subclassing, and like, you just want me to accept that now I shouldn't use it, right? Subclassing is awesome, right? I love subclassing. Just writing this little thing. I've been writing so much functional programming in this class. I like just starting to get a hint and a whiff of like subclassing makes me want to just build a class hierarchy that's way overdone right now. And it's really, really convenient, right, to just extend things. In a lot of ways, this forwarding of methods that I had at the beginning is kind of annoying, right? And you can see where you're like, you can convince yourself that, it's not that bad if I extend this thing, I get everything for free and I don't have to maintain all these delegates, right? One solution to that is Desire language that makes delegation automatic. Again, I'm not a Kotlin expert, but they seem to have like some automatic delegation. And a lot of times, if you're going to do something that's wrote, or your editor is going to do something that's wrote, like the language or the editor can handle it for you. In Ruby, they do things like the accessors and readers and writers. Kotlin has a lot of that too. The one thing to remember is that there are very real constraints on the flexibility of your system when you choose to subclass. You're locking in this relationship forever when you say that I subclass this other class, and you just need to be aware of that. For some further reading on this subject, and sort of like looking up stuff about this, I found this really nice page on MIT about how to, and had some really good examples. It also references this effective Java book that I really like, that I'm also going to point you to. Anybody who's really interested in Java specifically, I can recommend this book. All the versions have been great, and Josh has thought way too long, and it's really nice to have someone who really knows, who has very strong and well thought out opinions on exactly how you should use a language, especially if you're going to use it a lot. So with that, I'll leave you with those two things to look forward to, or to read further, and I hope you enjoyed this video.